back to another lesson. Today's learning goal is I can factor the greatest common factor out of polynomials. So let's go ahead and get started. We talked about in class what the greatest common factor is and how to identify it. So first what we're going to do is look at the coefficients. Okay, so 12 and 36. What is the largest number that divides evenly into both of them? Well, the answer to that is 12. So we're going to factor out a 12, or the greatest common factor is 12, and then we look at the variables. What variables do they have in common? Well, here they both share at least one x, because this has two x's, this is one x. So the greatest common factor is 12x. Here we have 45x squared plus 9x, 45 and 9. They both have 9, and they both have an x, because this is x squared and this is x, so our greatest common factor is 9x. Here we have a negative leading coefficient, right there, negative 8, which means when we're factoring this out, we want to factor out a negative. Whenever we have a negative leading coefficient, we want to factor out a negative. So here we're going to factor out 8 and 12 is 4, so we're going to factor out a negative 4 and a single x. Here we have 2x squared plus 4x plus 7. 7 does not share any common factors with 2 and 4, so here, because they have this has x squared and this has x and there's no x's, we don't have a greatest common factor, so there is no greatest common factor. Go ahead and try number 4 out on your own. The greatest common factor here is going to be just 5, because this last term right here does not have a b, so we cannot factor out a b. A polynomial with the greatest common factor can be factored out by dividing out the greatest common factors. So first we have to determine what the greatest common factor is. Right, the greatest common factor on the left side of the parentheses, or excuse me, on the left side of the graphical organizer, or the set of parentheses. So right here, we've done that right here. And then divide each term by the greatest common factor. So let's figure out, first of all, what's the greatest common factor of this first one right here. 15x squared plus 5x. Well, here we can factor out a 5x, and what that leaves us with, so this length is 5x, and if that length is 5x, that means that this length right here is going to be 3x, because 3x times 5x goes 15x squared. And then this length right here is going to be 1, because 1 times 5x goes 5x. So therefore, when we factor it out, we get 5x, parentheses, 3x plus 1, parentheses. So we're undoing the multiplication. That's exactly what we're doing with factoring. We're undoing the multiplication. Okay, so undistributing to a certain extent. Here we have 32x squared. So let's write that 32x squared and 12x. Let's factor out the greatest common factor. The greatest common factor of this is going to be 4x. That is 32. 12, the greatest common factor is 4. And that means that 4 times 8, x is going to get us 32x squared. And here, this is simply going to be 3. So what we have is 4x times 3x plus 3 gets us 32x squared plus 12x. Here we have 8r squared negative 40r, because remember this is a negative 40r, minus 16. Here we have a positive leading coefficient, even though the rest of them have negative coefficients. Because we have a positive leading coefficient, we only have to factor out a positive. And the positive number we're going to factor out is simply just 8. 8. And because this does not have r right there, so this is simply 8. We do that, we have r squared minus 5r minus 2. And so our factored expression is 8 times r squared minus 5r minus 2. So here it says use the parentheses to factor the polynomials, then check your answer by applying the distribution property. So here we have a positive leading coefficient. Even though negative 6 is right there, because this is x squared, we have a positive 12 as our leading coefficient, which means that we're going to factor out a 6x. That makes it negative 1 plus 2x. And typically we write it with the leading coefficient first, so I'm going to erase this again and write 2x. Oops, hard to see that. 2x minus 1. 2x minus 1 instead, because we want to try to have the leading coefficient first. So 6x times 2x minus 1. And if we distribute that back in, we get 12x squared minus 6x, back to what we had originally right here. Go ahead and try number 8 out on your own, including the check. What you should have gotten is that the greatest common factor here is 4. We have 9h squared plus 16h plus 2 after we divide each term by 4, and we can see the check works out here.